Okay, so today we're solving and writing equations. And so what you're going to notice is example 1 is going to start out a little bit easy, and then we're going to get a little bit more complex as it goes. Okay, so just be ready. When we did our review yesterday, the little booklet, that was a review to kind of help our brains get going. Today we're actually doing more like Algebra 1 type. Okay, so when we do an equation, when we're going to solve an equation, I like to draw a line down the equal sign. And I know this space is a little bit small if you write large. So one thing that I do with some of these, if you wanted to, if you write large, you could rewrite this example like sideways like this, and then write down this way, like turn your journal and write down that way if you want to, just saying. Okay, so I draw my line down the equal sign. Next thing I do is I box in my variables and I include the coefficients. So when I box in, I would box in negative 11j. But then I notice I have another thing I have to box in, positive 3j. So a lot of people say, oh, this one has two variables, which is actually not accurate. Two variables would mean it has two different letters. But I agree, it has two terms that both have variables in them. But these are alike, right? Like one's a J and the other one's a J. So the way we say that in math is we're going to combine like terms. I think about it like the grocery store, all right? So when I go in the produce section, they have those little plasticky bags, right? So when I go get my apples, I put my apples in one bag. And then when I'm getting my stuff for like my dinner recipe, I get my onions and I put that in a different bag, because you don't want to put your onions in the same bag with the apples, because that's weird, right? It also isn't very nice for the cashier. Like that's why you put it all in separate bags, so that when they put it on, it's like one thing. So that's like combining like terms in math. We can only put the same things together. So the J and the J, we can combine those. But the other thing I want you to notice is, aren't they on the same side of the equal sign? So if they're on the same side of the equal sign, when we combine them, we literally do exactly what signs it tells us. So it says negative 11j plus 3j. So if you struggle with the integers, which a lot of people do, we literally in our calculator are going to be typing negative 11, but we can't type the j, all right? We just have to know we've got negative 11 and then plus 3 and enter, and we get negative 8. So now instead of having two separate boxes that are like terms, we're going to just write it as negative 8j. Minus 6 equals negative 30. Now it looks more like an equation that we worked on yesterday. So when I box in my variable now, I just have one box, so that's good. So now we're at that section where we've got the box and then we have the lonely number. So do I need to worry about the box or the lonely number first? The lonely number. I need to get this negative 6 to the other side with the other constant. So instead of minus 6, to move it, I would add 6, because I always do the opposite sign. And what I do to one side, I have to do to the other, because that makes it fair. Then I bring down the negative 8j, because we haven't done anything with that yet. I get to cross out the minus 6 and the plus 6, because those canceled out, and it's satisfying to cross those out. And then I have negative 30 plus 6. So in our calculator, we would type negative 30 plus 6, and we get negative 24. That's one of those that most of you would do in your head, but just know there's no shame in checking it in the calculator and making sure that you get it right. Because if you mess up that step, are you going to have a wrong answer? Yes. Now, last thing I notice is I have this negative 8 stuck to the j. So remember, that's like a couple, right? They're like hanging out, they're multiplying, that's gross. Just because the 8's negative, that just means like he's not a great friend, right? He's a negative friend. but we still divide them apart. We don't care that it's really negative. Like, we don't think about adding or anything of that. We just say, oh, -8, we're dividing you away from j. And so then we divide by -8 on the other side. So I'm left with j equals 3. And it's a positive 3 because a negative divided by a negative is a positive. So got a little bit harder because we had to combine like terms, but not too bad. Now we go example 2. And we are like, oh no, it has parentheses in it. Okay. When we see parentheses, most of my students, the first thing they say is PEMDAS. We got to do parentheses first, right? But that's not really what this is about in an equation. Because if you look inside the parentheses, 3r plus 2, can you add 3r plus 2 together? No, because one has an r and the other one doesn't. So that's like an apple and an onion. We can't add those together because they're not exactly the same. So we're not really using PEMDAS because we can't add those together. So remember in algebra, instead of writing multiply as a like little x, a lot of times I'm going to write multiply as a parentheses. So that's really what this is saying. This is saying -5 times 3r plus 2. The math word that you guys have heard because you watched that video, it's called the distributive property. Okay. I call this, though, sometimes the rainbow. Because here's what I do. In order to remember that I have to multiply in both terms, I draw a rainbow. So see that -5? We're going to draw a rainbow. Let's go green. To 3r and a rainbow to 2. So the reason I draw those rainbows is to remind myself it has to distribute to everything inside the parentheses. So what we would be left with, I would bring down the 12 because it doesn't get to get distributed. Only the thing that's stuck to the parentheses gets distributed. Now I have -5 times 3r. So what's -5 times 3? -15, and it would be r. Good job. But I drew this rainbow to remind me that I also have to distribute the -5 times the +2. So what's -5 times +2? -10. Good job. Because -5 times +2, a negative times a positive is a negative. So we just use the word -10, and when I wrote it, it looks kind of like a minus sign, right? Because in this case, it actually does become a minus sign, okay? Then I bring equals 17. So before I start moving stuff around, I'm looking at like, oh man, I have like 3 terms over here. And if I box in my r, I'm like, well, at least I only have 1 box, so that's good. But what you notice is I have 2 lonely numbers on the same side. So before I start moving the lonely numbers to the other side, I'm going to combine like terms on this side. So what's 12 minus 10? 2. So I would get 2 minus 15r equals 17. And you guys are doing a great job while you're taking your notes, but do you notice like I'm literally writing every single step down? I have some students who try not to write because like their hand's going to fall off or something. But like if you don't write every single step the way that we're doing it, you're going to make a silly mistake. Okay. All right. So at this point, we need to move the lonely numbers to the other side of the equal sign. So I know I need to move this 2, but I don't know how to move it. Why subtract?
Because it's positive.
So how do you know it's positive? Because it doesn't have a plus in front.
But it doesn't have a negative.
But it doesn't have a negative. So absolutely, if it isn't shown as a negative, then you know it's positive. So excellent. So I have to subtract it to move it. Great job. Now I'm going to cancel those 2's out. I'm going to bring down the -15r. And then 17 minus 12 is 15. I said 12, but it's 2. 17 minus 2 is 15. Last thing I've got to do is divide those multipliers up because that's gross. So I'm going to divide by negative 15. What I do to one side, I have to do to the other side. Negative 1.
This is so easy.
You're so awesome. Y'all are doing great.
Do you have homework on this?
Mm-hmm. So this is Algebra 1 style, okay? But then you're going to get to example 3 and you're going to see how Algebra 1, bless you, gets a little bit more tricky. It's the exact same thing we just did, but like a little bit more of it, okay? So first thing we do is draw our line down the equal sign. And in our head we think, oh, I see parentheses, so that means I'm going to distribute. And the way I remember to distribute is I draw my rainbows. When you distribute, you only distribute to the parentheses that it's touching right there, okay? It's kind of like that negative 1 is giving a hug to the V and the negative 4, but you got to like distribute to both of them. Give the hug to both. But then you rock along and you see I have a positive 4 and it has a parentheses too, so we're going to draw those rainbows as well. Now we're going to just work through what that means. So 3 has nothing going on, so I just bring the 3 down. Negative 1 times V would be negative 1V. Negative 1 times negative 4 is positive 4, because a negative times a negative makes a positive. I have this guy, I call him Mac Daddy, and he looks like this. And I give him a little hat, and it says MD, so it only works for multiplication and division. So if I have a negative times a negative, the answer is positive. Okay? I'm going to keep strolling on, and I see positive 4 times positive 2V would make 8V. It's positive 8V, so I'm going to actually write plus 8V. And then positive 4 times negative 9 is
Negative 36.
okay. So we got rid of the parentheses, so it's not as scary. But now what I like to do, remember I like to box in my variables. And so when I box in, I notice I have 2 boxes, but they're on the same side, so that's okay. Those are like terms. We can combine those together. So what's negative 1V plus 8V?
So it's 7.
Positive 7V. Then I see I have a lonely plus 4 and a lonely minus 36, and those are on the same side, so I can combine those as like terms. So I would do positive 4, or 4, minus 36.
It's negative.
What is it?
Negative 28. 30. No.
Negative 32.
Oh, yeah.
Okay. And the 3 is still boring over there, and it's just hanging out over there by itself. Now we finally got it where it looks kind of like what the simpler equations are from back in the day. I need to move this lonely negative 32 to the other side. So add 32. Good. So I get 35 equals 7V. But we're showing all our steps. So we have that 7 and the V, they're multiplying, that's gross. We divide by 7 both sides, and we get V equals. Okay, I'm going to tell you a couple things. I did this one on purpose where the V ends up on the right side instead of the left. For some of my students, it just freaks them out that the V is on the other side of the equal because you're so used to the letter being on the left. But you know that equal means equal. So I could rewrite this as V equals 5, right? Because equal means equal, so I could literally flip-flop it if I want to. Okay, so how are you feeling? Great. Now we're going to go example 4. And this is where some peeps start getting a little bit scared because we're writing the equation now. So I gave you it in words, and we're writing an equation. This is truly one of those skills that the more you do it, practice makes perfect kind of deal. And everybody dislikes this, but you're only going to get better when we practice more. So here's my strategy. I start at the very beginning of the sentence and I work as slowly through it as possible to make sure, like, I just go word by word. So I see 7. So what am I going to write? 7. Then I see the word plus. So plus means add. So we're feeling pretty solid at this point. The quotient of, this is where we all get freaked out, right? Quotient is like, okay. So Q is like kind of a fancy letter. So the last thing you learned when you were little, you learned how to add, then you learned how to subtract, then you learned how to multiply, then you learned how to divide. Okay, so out of the 4, dividing was like the last one. It's the fanciest one because you had to like learn all these other ones first. So when you see quotient, it's fancy. That means that's the hard one. So it's quotient means divide. Time out. Okay. So quotient is fancy. So that means divide. So the quotient of, but we don't know what we're dividing yet. Okay. So, but divide, we're going to write it as like a fractiony thing. So remember divide, we can do like a fraction instead of like this little division thing. So the quotient of a number, but we don't know what the number is. So if we don't know what the number is, that's our variable. So our variable can be any number or any letter we want it to be. So we typically go with X, so I'll go with X. So if you're doing the quotient of a number and 5, that means 5's on the bottom.
Is it okay if we did like B or something?
You can use any letter you want to. You can use any letter you want to. Just most people feel more comfortable with X because that's just what you've seen. And then you get to this 2-letter word is. It's my favorite one. Is equals. So we put equals -12. And now you just wrote a fancy equation, an Algebra 1 equation, and now we get to solve it real quick. So we're going to draw our line down. We're going to box in our X and we're going to notice, okay, it kind of looks like a fraction, but really that's a division, but we'll get to that in a minute. I'm going to move the lonely to get to the other lonely, so I'm going to subtract 7. I get to be really careful and cross out those. It makes me happy. Then X over 5 equals -12 minus 7. So I'm just going to take a timeout, even though I know we're kind of in a hurry. When you type that in, you type in -12 minus 7, like that. Some of my students type in -12 minus -7, and that's completely different.
That'll add it. That'll be -12 plus 7.
So absolutely. So we get -19. Last step I got to do is this line means divide, so the opposite of that is multiply. But what I do to one side, I have to do to the other. So these 5s, because they're diagonal, they cancel. So I'm left with X equals -19 times 5 is a huge -95. That was really scary, but it's okay. No one's injured. We're good. Last example. An odd integer. So even when I just start reading that one, it's a little bit scary, right? Odd means not even. So odd numbers are like 1, 3, 5, 7. That's an odd integer. Integer is just the fancy word for positive and negative whole numbers. Kind of learn that more in 7th and 8th grade. An odd integer can be represented by the expression n plus 2. Where n is any odd integer. This sounds like just like the kind of wording that they would use on like a worksheet or a star test. Like that sounds very like that, right? The other one sounds like how Miss Merle would write it. This sounds like how the state of Texas would write it. Find 3 consecutive odd integers. So I'm going to take a timeout. Consecutive means in a row. So if you win like 3 consecutive basketball championships, that means you won 3 years in a row. Consecutive means in a row. But if you're 3 consecutive odd integers, that would mean like 1, 3, 5. Those are the odd ones in a row, but it skips those even ones, okay? So if they have a sum of negative 51. So, okay, the first odd integer is going to be n plus 2 because that's what they told us that we could represent the first one by. The one before that is just n. The one after that is n plus 4. The reason it's n plus 4 because it skipped that even number in between. So our equation is going to be n plus 2 plus n plus 4 equals negative 51. The reason I put plus signs in between is because it said it has a sum of negative 51. So I know this one's a little bit tricky. Don't stress. You don't have a homework one just like this, but I just wanted to show you it. So I have 1n, 1n, 1n. So how many n's? When I combine like terms, I get 3n. Combine those, we get plus 6 equals negative 51. Draw that line. I forgot to draw the line. So I move the 6 by subtracting. I get negative 57. Divide both sides by 3. N equals negative 19. But it says find 3 consecutive odd integers, so it would be negative 19. The next one would be negative 17. The next one would be negative 15. Because remember, when you're negatives, you're going like, it seems kind of backwards when you're going ahead. Okay, so that's that.